Assalamu alaikum everyone, welcome to Mathematics with Shahab Yaqub. Now we are on algebra and this is lecture number 24. We know that algebra is a very lengthy topic. We are almost till the very end. And now we are focusing on sequences part 1. Sequences are also known as number pattern. Sequence, pattern, they mean the same thing. So let me highlight sequence, let me highlight pattern. Now let's look at the syllabus content. So I have written sequence over here, that's the number pattern. And what is the thing that's in here? Part 1, continue a given number, sequence or pattern. Part 2, recognize pattern in sequences including the term to term rule and relationship between different sequences. Now, what are the different sequences that we'll be dealing with? So let me get the highlighter ready. There is the linear sequence, there is the quadratic sequence, there is the cubic sequence, and there is the exponential sequence. And we are interested in a simple combination of these. So a simple combination of these, and they can be treated separately also. And when we talk about the first part, we are talking about subscript notation may be used. Example, Tn is the nth term of the sequence. And let me focus on this one. And the last one, that is find and use the nth term of the sequences. So there are some formulas that we will be using. So formulas for nth term, in some cases, we'll be using these formulas. So now the very first thing is that let me write down some different kind of sequences. For example, if I write 0, 2, 4, 6, 8, you can guess what is the next number. The next number is 10. Now this is an even numbered sequence, a sequences of even number. So each number is increased from the previous number by the addition of 2. 0 plus 2 is 2, 2 plus 2 is 4, 4 plus 2 is 6, and so on. So this is a sequence. We will call it an arithmetic sequence. And why will we call it an arithmetic sequence? Because the difference is constant. Let me write down another arithmetic sequence, and maybe you are well aware of what exactly I'm going to write. So I'm going to write that 1, 3, 5, 7, 9, the next one. The next one is 11. Now this is also an arithmetic sequence, but this time this is a sequence of odd numbers. So that is for even numbers, this is for odd number. Each number is obtained from the previous number by addition of a constant value 2. So again, I can write that this is an arithmetic sequence. Let me write another example. Something like 100, 90, 80, 70, the next one is 60. Now this is a number pattern such that there is an addition of negative 10. I'm still using the word addition, so therefore it is again an arithmetic sequence. Again the difference is constant. What is the difference between the previous two and this one? There is an addition of a constant value. This value was positive. This is also addition, but this is a negative number. So this is also an example of an arithmetic sequence. Let me choose a sequence. And this time, let me focus on multiples. So 3 ones are 3, 3 twos are 3 ones are 3, so let me write the 3 first. This is 3, this is 6, this is 9, this is 12, the next one, that is 15. So now this is multiples of 3. So this is like this. 3 plus 3 is 9, 9 plus 3, 6 plus 3 is 9, 9 plus 3 is 12, 12 plus 3 is 15. So can I write this thing as an arithmetic sequence? Yes, this is also an arithmetic sequence. Why? Because there is an addition of plus 3. So now we have seen 4 different kind of sequences. They all are arithmetic. This is of even number, this is of odd number, this is just an addition of 2, and this is multiples of 3. Let's deal with some negative numbers. Let's say I have negative 5. Actually, let me start with negative 20, negative 15, negative 10, negative 5, 0. The next one is positive 5. This time there is an addition of a constant value of 5. A plus 5 is being added. So therefore this is again an arithmetic sequence because the difference is constant. Now since we are so much involved with arithmetic sequence, I think it's a good idea. So get started with the concept of arithmetic sequence. So arithmetic sequence or number pattern. Let me give it a symbol A, that is for the first term. And let me write D, that is the common difference. So there is a first term and then there is a common difference. Then let me write N, that is the number of terms. Let me write T subscript N, which we have seen in the syllabus above. So this thing over here, Tn, that is the nth term of a sequence. So this is the nth term. And let me write a formula that connects these all 4. Therefore, Tn is A plus n minus 1 into D. That means if I have the first term, if I have the number of terms, if I subtract 1, I multiply with D, add A to it, I'll get any particular term. So nth term can be also written as any particular term. So now, how is it applicable over here? Let me choose the first one, 0, 2, 4, 6, 8, 10. So let me write over here, 0, 2, 4, 6, 8, 10, and so on. The first term is 0, so I'll write A as 0. The common difference, that is second minus the first term, third minus the second, and so on. So T2 minus T1, T2 means the second term, T1 means the first term. That is also equals to T3 minus T2. That is also equals to T4 minus T3, and so on and so on. So over here, the common difference is 2 minus 0, which is 2. 4 minus 2 is also 2. What else is there? I know that the next term over here will be 12. Can I calculate this? The answer is yes. So therefore, let me just change this color to purple and this color to green. Okay. So now over here, if this is the first term, this is the second term, this is third, this is fourth, this is fifth, this is sixth, I'm interested in seventh, which I know is 12. So if I plug in n is equals to 7, can I use this formula right over here and calculate the seventh term? The answer is yes. So therefore T7 should be A plus 7 minus 1 into D. Instead of n, I have plugged in 7. A is 0, 7 minus 1 is 6, the value of D is 2, this is 0 plus 12, And yes, the answer is 12, which we already know from our observation. That means I can use the term formula to find a particular term. So out of these four things, this is first, this is second, this is third, this is fourth. If three are given, you can naturally find the fourth one. Let me focus on some other series. Let's say 3, 6, 9, 12, and dot, dot, dot. These are multiples of 3. Remember, I have 33. So I can count on my fingers that this one is the first term, second, third, fourth, and this is the 11th term. 3 11s are 33. But I want to use the formula. So let me write down the formula over here. That is Tn is equals to A plus N minus 1 into D. Now exactly what do we have over here? We have the first term, that is A. So A is 3 in this case. We have the common difference, which is 12 minus 9 or 9 minus 6 or 6 minus 3. So the common difference is 9 minus 6, which is 3. We have a particular term, the nth term, which is 33. We want to count it all the way up till 33. So Tn is 33. So what is the missing piece of the puzzle? That is n. So let me write over here. Tn is A plus N minus 1 into D. Tn is 33, A is 3, N minus 1 is N minus 1, and D is 3. So let's do the calculation. 33 minus this 3, that's right over here, is equals to N minus 1 into 3. This 3 is this one, so that you don't confuse both of them. 30 is equals to N minus 1 into 3. 30 over this 3 is N minus 1. 10 is equals to N minus 1. Therefore, N comes out to be 11th. In other words, 33 is the 11th term of this progression, of this series, of this sequence, of this number pattern. Series, sequence, pattern, progression. These are the different terms that are being used. So that is the basic idea of such an example. So I can use any one of these three. If 3 are given, I can find the fourth one. If these 3 are given, I can find the fourth one, and so on. So that is the basic idea of this thing. Now let me choose another kind of sequence, and let me just write down some square numbers. So let me write down over here, and some other sequences. They do not necessarily fit into any particular category. So let me make some other sequences. For example, let me write for square numbers. So let me just adjust one thing right over here. I'll just pause the recording. So now let's look at some other sequences, such as a sequence of square numbers. So if I talk about square numbers, I'll talk about 1 square, which is 1, 2 square, which is 4, 3 square, which is 9, 4 square, which is 16, 5 square, which is 25, 6 square, which is 36, and 7 square, which is 49. So now this is basically Tn. Let me write it over here. So over here, Tn is n square. So when n is 1, T1 is 1 square, T2 is 2 square, T3 is 3 square, and so on. Now let me do some variation in it. So let me just take these square numbers and subtract 1. So this is square numbers and add 1, okay, and then add 1. So 1 square plus 1, and this is 2 square plus 2. This is 3 square plus 3. Actually 2 square plus 1, we are just adding 1. So 2 square plus 1, 3 square plus 1, 4 square plus 1, and so on. So therefore the sequence is what? Tn is equals to n square plus 1. That is another sequence. Got the idea? Let me do something else. Square numbers and add n. That means I can write 1 square plus 1, 2 square plus 2, 3 square plus 3, 4 square plus 4, 5 square plus 5, and so on. So what is the sequence? The sequence is Tn is n square plus n. If n is 1, it's 1 square plus 1. If n is 2, it's 2 square plus 2. If n is 3, it's 3 square plus 3. Similarly, 4 square plus 4. So this is about square numbers. Let me talk about some other sequences. So let me write over here more examples. Something like cube numbers. So if I talk about cube numbers, let's say 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube is 64, 5 cube is 125. 6 cube is 216. Let me write it down. So cube numbers, Tn is equals to n cube. Similarly, I can have cube numbers and then subtract 1. So 1 becomes 0, 8 becomes 7, 27 becomes 26, 64 becomes 63, 125 becomes 124, 216 becomes 215. So the sequence over here, that is Tn is n cube minus 1. What about a pattern is made by combining a square number pattern, square plus cube. So therefore, this time let me write the pattern over here. Tn is n square plus n cube. Someone can make it up like this. So therefore, this is 1 square plus 1 cube, and this is 2 square plus 2 cube. This is 3 square plus 3 cube, and 4 square plus 4 cube, and so on. So this is 1 plus 1, which is 2. This is 2 square is 4, and 2 cube is 8. 4 plus 8 is 12. 3 square is 9. 3 cube is 27. That comes out to be 36. 4 square is 16, 4 cube is 64, so 16 plus 64, that is 80. So of course they will give you some kind of hint so that you have an idea exactly what is happening, but these are just some examples. Maybe it could so happen that we are dealing with some kind of fractions. So let's say we are dealing with fractions, and we know that a fraction is made up of a numerator and a fraction is made up of a denominator. So let's say I have a fraction like this. This is 1, and let me write 2, let me write 3, let me write 4, let me write 5. So 1, 2, 3, 4, 5. Let me just change the colors of these 5. So let me write them in red color. And then underneath, this is 1 square, this is 2 square, this is 3 square, this is 4 square, this is 5 square. Maybe a pattern like this. Someone can make up a pattern. So if I talk about the numerator, that is a pattern of 1, 2, 3, 4, 5 treated separately. This has a fixed difference of 1, therefore this is an arithmetic sequence. If I talk about the denominator, that denominator is like 1 square, 2 square, 3 square, 4 square, 5 square. This is what? This is a sequence of square numbers. So we are dealing with two different things at one time. So there is a numerator, a sequence of arithmetic sequence, and denominator square numbers that is like kind of exponential because it's about the powers. Okay, let me add one other thing over here. This is like cube numbers, square and cube, something like what about, or let me add over here. First add, then square. That could be a possibility too. That means I can write Tn as n plus 1 whole square. So let me just take this on the next page. So let me cut it. Let me add over here before we go to the cube numbers. So let me write over here and let me put some more color over here. So this is some more examples of square number sequence. First add, then square. That means I can write this thing as 1 plus 1 square, and then let me write it like this. First of all, hold for a second. T1, this is 1 plus 1 whole square, which is 2 square, which is 4. T2 is 2 plus 1 whole square, which is 3 square, 9. T3, this is 3 plus 1 whole square, which is 16. T4, which is 4 plus 1 whole square, which is 25. T5, which is 5 plus 1 whole square, which is 36. So basically, this n is over here, this 1 is over here, 2 is over here, 3 is over here, 4 over here, 5 over here, and then I'm adding a 1. So this 1 is added, this 1, 1, and then we are squaring it. So basically T1 is not the square of 1, T1 is the square of 2. So T1 is square of 2. And similarly T2, it's square of 3. And T3, it's square of 4. And T4, that is square of 5. And T5, that is square of 6. That is what is happening over here. First add, then square. Got the idea? Someone can also say this. First subtract 1 and then square. Let's try this one out also. It's just exploration. Once you explore the maximum possible things, then you will have a very good understanding when you see the questions, because you have explored it all. So in today's class, we are exploring it to the max. So first add 1, then square. And this one is first subtract 1, then square. So let me write over here, Tn is n minus 1 whole square. So let me then write it down in the same manner. T1, it's 1 minus 1 square, which is 0. T2, this is 2 minus 1 whole square, which is 1. T3, which is 3 minus 1 whole square, which is 4. T4, which is 4 minus 1 whole square, which is 9. T5, that's 5 minus 1 whole square, which is 60. Now again, focus on this. 1 and this 1. 2 and this 2, 3 and this 3, 4 and this 4, 5 and this 5, and this negative 1 was constant. We are subtracting 1, or addition of negative 1 means the same thing. So basically T1 is the square of 0. Got it? And T2 is the square of 1. And T3 is the square of 2. And T4 is the square of 3. And T5 is the square of 4. Got the idea? Loud and clear? So these are some examples that we have seen. And then we dealt with cube numbers and dealt with different kinds of fractions. As far as the exploration is concerned, so let me also focus on this. that let me choose something like, let me just focus on this. Okay, so let me choose something like a quadratic thing. And let's say we are dealing with a quadratic sequence. Now, what exactly is a quadratic sequence? Let's see. You will learn, I'll learn. Let's say it's of the format n square plus n plus 1, and this is your Tn. And then we will look for some pattern over there. If it exists, we don't know. So n square plus n plus 1. Let me write T1, that is 1 square plus 1 plus 1. Let me write T2, that is 2 square plus 1 plus n. So n is 2 plus 1. T3 is 3 square plus 3 plus 1. Let me write T4, that is 4 square plus 4 plus 1. T5, that is 5 square plus 5 plus 1. I think it's following the pattern. Let's just minimize and have a look. Let me grab the highlighter and let me make it bigger. So this is n square, this is 1 square, 2 square, 3 square, 4 square, 5 square, and this is 5, 4, 3, 2, 1. And then we are focusing on n. So therefore this is 1, this is 2, this is 3, this is 4, this is 5. And the last one, 1 is just constant. So 1 is just adding, it's unchanged, it's not dependent on n, it's a fixed value, it's kind of independent. So now let me focus on T1. So T1 comes out to be 3. T2 comes out to be 4 plus 2, 6. 6 plus 1 is 7. T square is 9. 9 plus 1 is 10. 10 plus 3 is 13. Double check with me. 4 square is 16 plus 4, 20. This is 21. 5 square is 25 plus 5, 30 plus 1, 31. So 3, 7, 13, 21, 31. 3, 7, 13, 21, 31. These are the first 5 terms of this particular quadratic sequence. Now let me focus on it like this. Let me find the difference between these two, between two consecutive terms. So the difference between 3 and 7 is 4. The difference between 7 and 13 is 6. The difference between 13 and 21, that is 8. The difference between 21 and 31, that is 10. This is called the first difference. Now, as you can see, this first difference is not constant, but it's increasing in an arithmetic sequence. So 4 till 6, there is a constant difference of 2 throughout. That means let me focus on the second sequence. So let me just change the color for this one. That is the first sequence. That is in red color. And let me calculate the second sequence. And that is like in green color. That is constant. Hold for a second. So now I'm focusing on the second difference. And the second difference is what? This is 2, this is 2, this is 2. That means the hard and fast rule is, if the second difference is constant, that means it is a quadratic sequence. So the first difference follows arithmetic sequence. If it follows arithmetic sequence, only then the second difference will be constant. So that is an example of a quadratic sequence. Let me give you another example. So another example of quadratic sequence. So this is purple color. Let me use the same color over here. So more examples on quadratic sequence. So let's say Tn is 2n square plus 3n plus 1, and this time I would like you to try it out. Calculate T1, calculate T2, calculate T3, calculate T4, calculate T5, and let's see if it follows the same rule like this. So let me pause the recording. Let me send you the images of this thing, and then we can continue ahead. So now we are explaining this particular thing. This is 2n square plus 3n plus 1. As long as there is a square, it's a quadratic sequence. So first of all, let me write T1, that is 2 into 1 square, 3 into 1 plus 1. So let me just fill up the pattern like this, so that it's easier for me to work it out. This is 2 into something square, 3 into something plus 1. That is 2 into something square plus 3 into something plus 1. And that is 2 into something square plus 3 into something plus 1. Let me even erase the small one from here. And from here, let me write it again. That is 2 into something square plus 3 times something plus 1. Now, first of all, this is n square. N is this thing. So this is 1, this is 1 square, this is 2, this is 2 square, this is 3, this is 3 square, this is 4, this is 4 square, this is 5, this is 5 square. And then over here, this is 3n. So whatever is the value that goes over here, 3 into 1, 3 into 2, 3 into 3, 3 into 4, 3 into 5. Now let's work it out. First of all, 2 plus 1, 2 into 1 is 2, plus 3 plus 1. 2 plus 3 plus 1, this comes out to be 6. That is the first number. 2 square is 4, 4 into 2 is 8, 8 plus 6, that is 14, 14 plus 1 is 15. 3 square is 9, 9 into 2 is 18, 18 plus 9 is 27, plus 1 is 28. 18 plus 9, all good. And then 4 square is 16, 16 into 2 is 32, 32 plus 12, 34, 44, 45. And last, 5 square is 25 into 2, 50, 50 plus 15, that is 65 plus 1, 66. So now we have these numbers 6, 15, 28, 6, 15, 28, and then we have 45, and then we have 66. Now let's focus on the first difference between these. So let me write over here the first difference. 6 and 15, that is 9, 15 and 28, that is 13, 28 and 45, I think that's 17, 45 and 66, that is 21. That is the first difference, which of course is not constant. Let me find the second difference, which should be constant, and that second difference is what? So now over here, let me write second difference. 9 and 13, the difference is 4, 13, 17, it's 4, 17, 21, it's 4. The second difference is constant. That means the first difference is an arithmetic progression, 9, 13, 17, 21. That means we have further solidified, consolidated the fact that yes, it's a quadratic sequence. So let's stop the recording at this one. This is lecture number sequences part 1. So this is lecture sequences part 1, in which we have done a lot of exploration on the different kind of sequences. Naturally, in the next class, we will be doing some questions related to number pattern. Till the very next class, take care and stay tuned to Mathematics with Shahab Yaqub.